Hello, and welcome to this lesson on solving one-step linear equations. So we're starting this new unit on solving equations. Each lesson is going to build on the previous lesson. So this is one-step equations. The next lesson is going to be two-step equations, and then multi-step equations, variables on both sides, and then proportions. So it kind of gets bigger as you go. So make sure you really take the time to understand the first lesson before you move on to the next. We can see the central question says, how do I solve one-step linear equations? Did you know that a one-step equation happens pretty much anytime you ask yourself a simple math question? Like, I have $4 and I'm going to the movies and it costs 10. How much money do I need to ask mom for? Well, that would be a one-step equation. We don't always do the equation in our head or say the equation or write it out, but it is really an equation that you're doing. There are two vocabulary words here for this lesson. The first one is just equation. We should probably figure out what this thing is. So an equation is a statement, a mathematical statement, where the value of one side of the equal sign is the same as the other. The two sides are equal. So 3 plus 5 equals 8 is an equation because both sides of the equal sign have the same value. The second word there is a reciprocal. The reciprocal is the upside down form of a fraction. If you take a fraction and you flip it over, that's a reciprocal. So if I have the fraction, say, 3/4, and I flip it, I move the numerator to the denominator and the denominator to the numerator, I would get the fraction 4/3. That is the reciprocal. We can also do that with something like a whole number, like, say, 5. I can take the reciprocal of 5 if I first turn it into a fraction. Most people know that the number 5 as a fraction would just be 5/1. To turn any whole number into a fraction, you put it over 1. Now that it's a fraction, we would just flip it. And now we'd get the fraction 1/5. That's reciprocal, and that's going to come in handy later on in the lesson. So the first skill of this lesson is being able to check the solution of an equation. Given an equation and given some possible solutions, we would like to be able to figure out which one is the correct solution. It says here at the very top that this is very useful with multiple choice questions. It is. It's very useful with multiple choice questions because sometimes you don't even have to solve the question if you can plug the values in for the equation and figure out which one's the right answer. So that's actually what we're going to do here. So in the first problem, we have 4x equals 20. And we're going to check to see if the numbers 2, 5, 8, and 10 are solutions to the equation. And we're going to check them until we find the right answer. I don't need to check them even after I've found the correct answer. So I'm going to start with the first one. I'm going to plug in 2 for x. And that's how you check the solution. You take the possible value of the solution and you plug it in for the variable. Now, the problem I have here in letter A says 4 times x. So when I plug in the 2, it's going to become 4 times 2 equals 20. And you can either do the math in your head, you can do it, write it out. We know that 4 times 2 is 8. So this math doesn't work out. 8 does not equal 20. This is not going, 8 does not equal 20. This doesn't work. So then you would check the next possible solution. If I plug in 5 for x, 4 times 5 equals 20. Again, do the math in your head or calculator. 4 times 5 is 20. This math actually does work out, which means 5 is the solution to this equation. So when x is 5, it makes both sides of the equal sign the same, which means it's true. That's what we're looking for when we're checking our solutions. Does the math work out? Is 20 equal 20? Yes. In the previous problem here, was 8 equal to 20? No. Okay, letter B. Come on. So we're going to do the same. We're going to take each of these and we're going to plug them in for H until we find the right answer. So the first one, if I plug in 2, 2 plus 3 equals 13. No, because 2 plus 3 is 5. 5 is not the same thing as 13. I didn't even need a calculator for that one. I'm going to plug in the 5. Is 5 plus 3 equal to 13? No. Again, I don't need a calculator, but to show, 5 plus 3 is 8. 8 does not equal 13. The math doesn't work out. If I plug in the next value, I'm going to plug in 8 now. Is 8 plus 3 equal to 13? No. 8 plus 3 is 11. So this math doesn't work out. 11 is not the same thing as 13, which means it pretty much has to be our last possible choice, 10. If I plug in 10, 10 plus 3 equals 13? Yes, because right here, my equation is true. Both sides of the equal sign are finally the same. 13 equals 13. That is the correct solution. So the answer is, when H equals 10, we have our correct solution. Okay, so I've done 2 problems. Now you're going to try 2 problems doing the exact same methods. You're going to take those same numbers, 2, 5, 8, and 10. You're going to plug them into these 2 equations and see if you can find which one is the correct solution. Pause the video, do the problems on your own. When you're ready to continue, hit play, and then we'll go through them together. All right, so the first one here. If I plug in 2 for D, 2 divided by 2 equals 4. I'm just going to check the work using calculator. I know it's not going to work because 2 divided by 2 is 1. Any number divided by itself is 1. 1 does not equal 4. That one did not work. I'm going to plug in the next number. I'm going to plug in 5. 5 divided by 2 equals 4. No, 5 divided by 2 is 2.5. 2.5 does not equal 4. This math did not work out. 8 divided by 2 equals 4. This is the next possible value. 8 divided by 2 actually does work. 8 divided by 2 is 4. So 4 equals 4. Yes, we found the solution. The correct solution was when D was equal, oopsie, not 8, when D was equal to 4. Let me try it again. The correct solution is when D was equal to 8, because when I plugged 8 in for the variable, it made everything work out. So D equals 8 was the correct solution there. Letter D. If you start plugging in your values here, -3 plus 2, I'm plugging 2 in for the variable, equals 5. No. On this calculator, this is your negative button. So -3 plus 2 equals -1. -1 is not the same thing as 5. That does not work. Then we plug in 5. -3 plus 5 equals 5. No, that's not going to work. -3 plus 5 is +2. Then I plug in 8. -3 plus 8 equals 5. This one actually does work. If we take -3 plus 8, you do get 5. This is the one that gives us the correct solution because we got the same value on both sides. That's what it means to have a correct equation. So when P was equal to 8, that's when we had the correct solution. I don't really need to check 10 because each of these equations will only have one solution, but if you did check 10, -3 plus 10 equals 5, That's not going to work because negative 3 plus 10 is 7. 7 equals 5 does not work. All right, so that was the first skill, how to check your answer. And that skill of checking an answer is vitally important for everything in pre-algebra and algebra and pretty much every math you're going to do past this point. So now let's actually learn how we solve an equation. These are all one-step equations, and a lot of these you can do in your head. But I caution you, don't just look at it and go, ooh, the first answer is 3. The second answer is 3. Yeah, we can do that, but I want to show you the proper steps and the logic behind it so that when these equations get harder in the next few lessons, you're still able to keep up and you still have the process down that you can go through. So the first problem here, to solve this equation, our ultimate goal is to get the variable by itself. I want this to be a y equals. Some people like to draw the line down their equal side to keep the two sides of the equation separate. So you have like your left side and your right side. So we want to solve this equation. In order to do that, we are going to do the opposite of what's happening to the variable. My variable is being added by 8. See, y plus 8. So in order to cancel out, we are going to subtract 8 on both sides. Another way to think of this is I have a positive 8. And in order to make this positive 8 go to 0, in order to make no more 8s on the left side of the equation, we have to subtract 8. So 8 minus 8 is 0. My 8s are gone. They've canceled out. On the right side of the equation, when I subtract 8, I'm going to do this math. 5 minus 8 is negative 3. This is the proper solution. And I can check my answer the way I just did in the previous few problems. So if I take y equals negative 3 and I plug it back in the original equation, so 8 plus y equals 5. And if I plug in a negative 3 for y, just like we were doing those previous problems, this math should work out. Is 8 plus negative 3 equal to 5? Well, yes, it is. So I solved the equation, and I was able to check my work to show that that is the correct equation, the correct solution. Letter B. So here, I look at my problem. I see that my variable is being multiplied by 12. This is a multiplication. When you have a number directly next to the variable, that's multiply. So in order to solve that equation, I'm going to do the opposite of a multiplication. I am going to divide by 12 on both sides. When you're solving an equation, you always do everything to both sides. You got to keep your equation balanced. So when I divide by 12 here, a 12 divided by 12 cancels. Little secret, doesn't actually cancel. We know for a fact that when you take 12 divide by 12 or put 12 over 12 as a fraction, it equals 1. This really becomes a 1m. But for the most part, I mean, we want a 1m. We want the m to be by itself. In the previous problem, this y here, there's 1y. We just don't write the 1. Same way here, this is a 1m. Well, I don't need to write this one. That's why I kind of wrote it in Ghost 1. I can get rid of that 1 anytime I want, and we're fine. Now, back up to here when we were solving the equation. So we took 36 divided by 12, and we got a solution of 3. I can stop here and just say the answer is m equals 3. It's the correct answer. Some people, though, they just kind of get in a robotic mode, and they see this 1m, and they go, oh, how do I get rid of this times by 1? And they divide by 1 on both sides, which to me is a little weird because you're really not doing anything. Look, I still have m equals 3, and technically speaking, There's still a ghost 1 there. But I'm just showing you some things that other students do. M equals 3 is the correct solution. If I would check that answer, 12m equals 36, and I'm going to plug that m equals 3 in for the variable to check to see if it actually still works. 12 times by 3 equals 36, and if I check my calculator, 12 times 3 equals 36. Would you look at that? So 36 equals 36. I checked my answer. This works. That is the correct solution. So now we've seen up here, I've solved an equation using addition. I solved an equation where the variable is being multiplied. The next two, I have an example where my variable is being subtracted and where my variable is being divided. So let's see. In letter C, my variable is being subtracted by 8. So the opposite of subtracting 8 is to add 8 on both sides. Another way to think of this is if I have a negative 8, how do you make a negative 8 go to 0? How do you make it cancel out? The answer is with using a positive 8. So on the right side, my 8s here, these will cancel out. They are gone. 0. Negative 8 plus 8 is 0. Negative 8 plus 8 is 0. They completely cancel out. On the left side of my equation, if I do the math, 5 plus 8 is 13. That is the correct answer. And if I check it, 5 equals p minus 8. I wrote down the original equation. I'm going to plug in the value I got for the variable. Oopsie, that's not a 13, that's a 5. And now when I check my math, I want to see, are these two sides of the equal sign the same? If I do 13 minus 8, will I get 5? Well, yeah. 13 minus 8 is 5. So now I've solved the equation and I've checked my equation, checked my solution. Letter D. My variable is being divided by 4. A is being divided by 4. So the opposite of that operation is multiply. I'm going to multiply by 4 on both sides. A multiply by 4 and a divide by 4 cancel. They're opposite operations. And when I multiply here, I'm going to take negative 16 times 4. Negative 16 times 4 equals negative 64. And I can check my solution if I take the original equation and I plug in that number. So negative 64, I'm plugging in my solution for the variable. Negative 64 divided by 4 is negative 16. Well, let's check. Negative 64 divided by 4 is negative 16. It works. Check. All right, so now I've done 4 problems. I've done an addition, a problem we solved using addition, a subtraction, a multiplication, and a division. So now it's going to be time for you to try. Here are 4 new problems. I want you to pause the video. I want you to solve each of them. And then when you're ready to continue, hit play and we'll go through them together. All right, so let's start solving here. I'm going to skip some work because hopefully by now you're finding these to be fairly easy. I'm not going to check each of the solutions as we go through. The check will be if you got the same answer as I got. So the first problem here, the variable is being added by 3. So we're going to subtract 3 on both sides. The solution is m equals negative 6. A negative 3 minus 3 more is negative 6. Letter F. My variable is being divided by -2, so I'm going to multiply by -2 on both sides. The multiply and the divide cancel each other out, so we get r equals -10 is our solution. Letter G, my variable is being added by a -3. See, w plus -3. This one's probably the trickiest of the bunch. So you may have thought about going, oh, I'm going to -3 on both sides. The problem is, this math here does not get the w by itself. -3 minus 3 is not 0. -3 minus 3 is going to be a -6. So we actually needed to use an addition. Because again, we wanted this variable to cancel out. We're going to have w equals something. So to get rid of this piece, we have to use a +3. To get rid of a -3, when we're adding and subtracting, we use a positive. And on the right-hand side, when I solve my equation, I'm going to get 12. Letter H. My variable is being subtracted by 6, or you could think of this as a -6. Either way, we're going to use a +3. 3. How about a +6 to get rid of it? So a -6 and a +6 cancel. A -6 plus 6 are opposites, and they cancel. Always on both sides, and we get the solution u equals 6. So hopefully you got all 4 of those right. Letter G, again, was probably the trickiest of them, so if you made a mistake there, no big deal. We'll get more practice. See? Told you so. Here are 4 more examples. Try these 4. Pause the video, hit play, and then we'll go through them together. All right, so let's do it. So we're going to start by doing a +4 on both sides. That cancels out this -4, and t equals 1. Letter J, we're going to solve by dividing by 7 to cancel out the multiply by 7. And we're going to get h equals 4. Letter K, we're going to solve by multiplying both sides by -7, because we're trying to cancel out this divide by -7 here. So this multiply cancels that out, and we get g equals, I don't know that math off the top of my head. -7 times by -14 is a +98. Make sure you keep track of your negatives when you are multiplying, especially when you're using your calculator. It's very easy to miss one of them and get a wrong answer. Letter L, the last of these, I'm going to divide by -2 on both sides because this was a multiply. This is -2 times q. So these cancel out, and we get q equals a +3. Again, because a negative divided by a negative is positive. All right, so skill 3. We want to be able to solve these equations that have fractional coefficients, rational coefficients. Something that is rational can be written as a fraction. So that's what this is. It says with a rational coefficient, this is a rational number, a fraction. So we want to be able to solve this equation. You can, with the use of your calculator, say, this is -2/7 times by x. This is a multiply. So if I divide by -2/7 on both sides, I should get the answer. And you're absolutely right. If I take 4, divide by -2 fraction 7. So this is your fraction button. I got negative 14. And you might be looking at that going, wow, that's a little weird. I'd expected to get a smaller number. Usually when you divide, you get a smaller number, not a bigger number. But it's correct. I can show you how to do this another way without the calculator. It takes a little bit of mental math. And it also takes that vocabulary word that we used up earlier. The word was reciprocal. We're going to find, to get rid of this fraction, the negative 2/7, we are going to multiply it by its reciprocal, by negative 7/2 on both sides. Now, what that does, if you would imagine multiplying these two fractions together, they're actually going to end up canceling each other out. A fraction multiplied by its reciprocal cancels itself out. Check this out. Negative 7/2, get out of the fraction, times by negative 2/7 equals 1. This is 1x. We talked about that earlier. We don't need to write that 1. So anytime you take a fraction and you multiply it by its reciprocal, you will always get 1. On the other side of the equal sign, if I take 4 times by negative 7/2, I said we weren't going to use the calculator. This just comes down to remembering how to multiply fractions. You multiply across the top, you multiply across the bottom, and then simplify your answer. So if I multiply across the top, I'm going to get negative 28. That is the 4 times by negative 7 is negative 28. Across the bottom, 1 times by 2 is 2. And if I simplify that fraction, well, what do you know? I get negative 14. Letter B. So to solve this equation, I can either divide both sides by 1/5 because this is a multiplication. If you have a calculator that can do that, divide by 1/5. If you don't have a calculator, you would multiply by the reciprocal. That's 5/1. And that would make the fraction on this right-hand side equal 1, because 1 times 5 is 5. 5 times 1 is 5. I'd get the fraction 5/5, which equals 1. Okay. When I multiply by 5/1 on the other side, I'm going to get the solution, the number 25. Now, this is kind of doing it by hand. The way you do it with a calculator is, if I take all this junk and delete it, and I'm going to, with my calculator, saying, hey, this ain't multiplied by 1/5. If I divide by 1/5 on both sides, k equals, let's see, 5 divided by 1/5 equals, it was that same solution. Now, it is very easy to use the calculator and just type the numbers and get it, but you should also be able to do this by hand. There are going to be some questions that you may need to do without a calculator, and this could be one because this is a skill that you have. You know how to multiply fractions and simplify fractions by hand. All right, so I've done 2. I'd like you to try 2 now. So try these 2 problems, pause the video. When you're ready to continue, hit play, and we'll go through it together. Alrighty-o, let's see here. So I'm going to do the divide method with the calculator just so you can help check your answer. Maybe I'll do one of each. This first one I'm just going to use the divide method. So I'm going to divide both sides by 3/4. A multiply by 3/4 and a divide by 3/4 cancel, so m equals, and then on my calculator, I'm going to do the math over here. I'm going to take a negative 6 divided by 3/4. So negative 6 divided by 3/4 equals negative 8. And hopefully you got the same answer no matter which method you chose. Letter D, I'm going to show you the doing it by hand method. So the by hand method is, instead of dividing by 1/3 on both sides, I'm going to multiply by the reciprocal. That makes this equal 1. Across the top, 3 times 1 is 3. 1 times 3 is 3. I would get the fraction 3 over 3, which equals 1. Y equals, and when I multiply by that same reciprocal on both sides, multiply across the top, we get 3. Multiply across the bottom, we get 5. And there we have it. We get the answer of 3/5. The last skill here in pretty much all the lessons is going to be a few little wordy problems. So this one says, Chris isn't going to install a fence that is 145 feet long. He's planning on putting a post every 10 feet. Write an equation to model the scenario and determine how many posts will Chris need. So let's see here. So if he's going to put a post every 10 feet, if you imagine like a 145 foot long section, and every 10 feet, boom, 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 obviously this is not drawn to scale, boom, 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 he needs a post. What math are we doing? Are we adding, subtracting, multiplying, dividing? What's division? Because we're going to take that 145 foot and we're going to divide it into equally spaced 10-foot sections. We're dividing it into sections. So if we took 145 and divided by 10, because there's going to be 10-foot sections, we're going to figure out how many sections he needs, or how many posts he needs. So this is an equation. I don't have to solve for the variable because the way that I set it up is just 145 divided by 10. Now if I do the math here, 145 divided by 10 is 14.5. Now this answer is a little strange if you think about it, because my next question down here says, well, why would a decimal answer not make sense in this situation? I got 145.5. I mean, I divided, just like we said. Well, do you think he really wants half of a post somewhere? No. He would need full posts for every single one of them. So saying 45.5 doesn't make much sense. You would probably need to round that up to, say, 15 posts he would need instead of 45.5. You wouldn't want half a post somewhere. So in the real life situation, there are a lot of times where having a decimal answer just doesn't make any sense. Letter B. James and Daniel both have Skittles. Daniel's has 3/5 the Skittles of James, who has 30. Write and solve an equation to determine how many Skittles Daniel has. All right, so let's see. They both have Skittles. James has 30. So James equals 30. I know he's got 30. But we don't know how many Daniel has. It says Daniel's has 3/5 the Skittles of James. So Daniel has 3/5 of James. Now, maybe you know this, maybe you don't. The word of in math, a lot of times, like 80% of the times, means multiply. So Daniel is 3/5 of James. I have an equation. And I can solve this equation because I already know that James has 30. It tells us that in the problem, and I have it written down up here. So now if I take 3/5 of 30, I got myself a solution. All right, 3 fraction 5, 3/5, get out of the fraction, plus 30. Now, why am I doing plus? Times 30, 3/5 of 30 is 18. Daniel has 18 Skittles. All right, 2 for me, 1 for you. It says here, Hank has collected 38 Pokemon. If he combines his collection with Jamie, they would have a total of 151. Write and solve an equation to determine how many Pokemon Jamie has. So I want you to try this one. So pause the video, try it on your own. When you're ready to continue, hit play, and we'll go through it together. All right, so let's see here. So Hank has 38 Pokemon. If he combines his collection with Jamie, think of that operation. If you're combining with somebody else, what are you doing? Well, you're adding. If he combines his collection with Jamie, they would have a total of 151. So we want to know how many Pokemon Jamie has. That's our unknown. That's our variable. So I just put a J for Jamie. Well, look at that little equation. We can solve that. We've solved equations like that earlier in the lesson. My variable needs to be by himself, which means I need to make this 38 go away. And the way we do that is we are going to subtract 38 on both sides. And when I take 151 minus 38, I get a solution of 113. Jamie has 113 Pokemon, while Hank has 38. I believe this is the last of these problems. So here, letter D, it says a factory produced many light bulbs yesterday. The factory then sold 3,457 light bulbs, and now they have 2,872 light bulbs left. Write and solve an equation to find how many light bulbs the factory produced yesterday. Again, pause the video, try it on your own. When you're ready to continue, hit play, and we'll go through it together. All right, so the factory produced many light bulbs yesterday. We don't know how many they made yesterday. Day. So yesterday, I'm just going to put a big old X, a variable. I don't know how many light bulbs they made yesterday. But then it goes on to say, then they sold 3,457 light bulbs. If you're selling your light bulbs, is the amount of light bulbs you have going to go up or down? It's going down. And it's going down by using a subtraction. So we're going to take away 3,457 of these light bulbs. And it says, and now they have 2,872 light bulbs left. So after we've taken this away, we would still have 2,872 left. Write and solve an equation. Well, through this process of talking through it, we've actually done most of that. If I take the equation, X minus 3,457 equals 2,872, there's my equation. And to solve the equation, I'm going to get the variable by itself by getting rid of this minus 3,457. We're going to add 3,457 to both sides. That is the opposite operation. These two cancel. So I'm going to get X equals, and on my calculator, I'm going to take 2,872 and add 3,457, and I get 6,329 light bulbs. Now, it's always a good idea when you finish a problem to make sure your answer makes sense. Does it make sense that yesterday they produced a lot of light bulbs or little light bulbs? Well, if they made a lot and then sold 3,000, if they made like 6,000 and sold 3,000 of them, roughly, would they have about 3,000 left? Yeah, that makes sense. But it's a good idea to check that and do that little mental calculation. Does my answer make sense in the word problem? All right, now for the summary. It says, now that you've learned about solving one-step equations, give a brief summary about what you've learned. So just write a little sentence or write a little thing. It's good to reflect on your knowledge. So what did you learn in this lesson? Pause the video, and then I'll go through some together. So things you should have learned. You should have learned that to solve an equation, you do the opposite of what's happening to a variable. So to get rid of the addition, you do a subtraction. To get rid of a divide, you multiply. You should have learned how to check the solution of an equation by taking a given number and plugging it in for a variable, like we did in the first examples up here. Nope, there we are. So we learned how to check a solution. We learned how to solve an equation by doing the opposite operation. We learned how to solve an equation with a rational coefficient. We learned you can either do it by dividing by the fraction using your calculator, or by multiplying both sides by the reciprocal, the upside down form of the fraction. And that makes the fraction cancel out. And lastly, we did a little bit of practice of setting up equations, writing our own equation from a word problem, and then solving. This has been lesson 1.1, or the very first lesson of solving equations. Thank you for watching. Toodles.